Hey guys, what's up? So today I found an interesting problem in the Leetcode and I solved it recently and I want to share the solution with you guys and talk up the problem in an understandable way. Okay, it's really a good problem and makes us understand how real world scheduling problems are solved. Uh, let's get right into it. All right. So let's see the problem statement first. There are a total of number of courses you have to take, and they are labeled from 0 to number of courses minus 1. So if you have 5, if you have 4, then really you have 0, 1, 2, 3 as the course. They are represented as 0, 1, 2, 3. Okay, so the main thing what it says is if num courses, right, yeah, num courses is 4, then you have 0, 1, 2, 3 as course list. Okay, so what it really says is you have a prerequisites. Okay, so the prerequisites is 2D array. So what you have to understand here is you will be having let's say 0, 1 and 1, 2, 1, 3. I'm just writing it here. Okay, it's just to give you an example. Okay, so just giving you the prerequisite list, and what it really says is if you want to complete the course 0, you have to complete the course 1. Okay, in the same way, if you want to complete the course 1, you have to complete the course 3. Okay, so in the same way, if you have to complete the course 1, you have to complete 2. So this is a 2D array, two-dimensional array, and the thing is here you have to solve by saying once you come up with, find the solution, you have to come up with an array which will give you a list of courses in some particular order. Okay, so let's say you say 0 is is dependent on 1, right? 1 is dependent on 3 and 1 is dependent on 2 as well. So 3 comma 2 comma 1 comma 0, right? So this is the order which the cursor has to be represented, and once it is done, you just find the length of this array, and once it matches with the number of courses, then you can return true, or else no. Okay, else return false. Okay, that way you have to come up with the algorithm. So I'll try to explain the algorithm in a more by giving you some analogy. I'll try to explain. Okay, so let's go to the board.
I'll try to explain the problem in an intuitive way. So let's consider a number of courses: arts, chemistry, metallurgy, biochemistry, biology, medicine, and oncology. Okay, so if you look at the tree, if you look at the structure which I have written, you can say arts doesn't have any dependency. Okay, so arts can be learnt in any order. Okay, but for the metallurgy and biochemistry courses, you have to first learn chemistry. So these two courses are dependent on course chemistry. Okay, so if you consider medicine, this again is dependent on the course biology, and oncology, if you consider, again here it is dependent on the course medicine, and of course the medicine in turn is dependent on biology. So if you look at two structures here, one is metallurgy, there is a direct dependent course which is chemistry, and biochemistry there is another direct dependent which is chemistry. Okay, for biochemistry. Okay, but for oncology, if you look at here, the direct course which is required here is medicine. Okay, but there is an indirect dependency for oncology, which is again the biology. Okay, so these are the two structures which you have to remember before solving the problem. Okay, so before I tell you how exactly we can achieve this, let's consider the courses which are given here, okay, based on the test cases. Okay, what the problem asking us to assume is, let's say you have 3 as number of courses. It is asking us to consider from 0. So 0, 1, 2 will be the total number of courses. So here what we have to return is, we have to return either true or false. True in the case where you can actually create a list from the conditions which are given, such that in the final list, in the final ordered list, the courses which you may get, I don't know, I'm just writing it here, which you may get is equal to the number of courses which are given. Okay, let's say I came up with an order 210. Okay, if I come up with that order, I can say that the number of items in this order is actually equal to the number of courses which is given, okay, as an input. So if that is the case, then I can say true, or else I have to return false. Okay, this is how you approach to the problem. Okay, first thing which you have to remember is, from the test case, from the conditions which are given 0, 1, 1 comma 0, 0 comma, in that way, the conditions, in that conditions you have to come up with an intuitive way where you need to fill an ordered list while you are going through the path of the graph which you will get when you try to form from the conditions. Okay, I'll tell you what I'm talking about when I say the path. Okay, let's say you are given 1, 2, 3, 4, 5, 6, 7 courses. Okay, so in these 7 courses I have given you one condition, I mean 2 conditions, and here there are another 2 conditions. Okay, so total 4 conditions are there in this particular case. Okay, so from this case, if I say I just write the beginning course as metallurgy, there is one path which is leading from here. Okay, if you want to learn metallurgy, you have to first learn chemistry, right? So when you write metallurgy, obviously you cannot, you've already reached metallurgy, so you cannot go back to chemistry. Okay, so for the same reason, what you have to do is, you have to construct one map, okay, such that you will have to say, like, if I get chemistry, I mean if I learn chemistry, what are all the things which I can learn next? So this is key and this is value. Okay, if you learn chemistry, you can learn metallurgy and you can learn biochemistry as well. So this is key value. Okay, so in this way you have to construct map, okay, where you will feel like that, in that way. So if I learn biology, I'm learning medicine, right? Okay, if I learn medicine, I learn oncology. Okay, in an intuitive way, if you consider this key and value map, obviously if you go through this keys, it is like you are going through a path in a graph. Okay, so ultimately what I'm trying to do here is, I'm trying to go through a graph which is obviously a directed graph. Okay, because from here you're reaching here, from here you're reaching here, so that is called directed. Okay, and obviously if you are coming here and if you are coming here and if you're again reaching here, there will be an infinite loop. Okay, so definitely that should be acyclic. Okay, so ultimately you have to sift through the traverse through the directed acyclic graph in such a way that finally, once you reach all the nodes, you will keep each and every visiting node in an ordered list, and then finally you will return that list, or you just check the length of the list and you say whether it is true or false. I mean, if it is equaling to number of courses, then you will say true or else false. Okay, so in this way you have to construct the key value pair, and then you take each and every key, which is essentially the nodes of the graph. Okay, because you take the key and you say chemistry is one node, and then you reach to metallurgy, right? So metallurgy is again another node. Okay, the same way, if you're originating from biology, you're going next to medicine, and then you need to check whether the medicine key is again existing in the map. Okay, once if it is existing, then you need to take that as source and you need to go to the destination, which is oncology. Okay, it is like from one course to another course, you are actually creating a path such that if you finish one important course, then you go to next important course. Okay, in that way. Okay. Now we saw if we get a map, how to traverse through the graph. Okay, but really how to create the map from the conditions which are given. Okay, in this particular case, based on how the test cases are written, if you consider in this particular example, what I can really say is, if you need to learn metallurgy, you need to learn chemistry, right? In the same way, if you need to learn biochemistry, you need to finish chemistry, right? So you have to take each and every value and say, like, if you are reading you need to take all the conditions at once. Okay, you just take each and every key and then check the value of the key, and then you need to check if that value is like it's already in a map which you are going to construct, by the way. Okay, so if chemistry is already there, since in this particular case it's not there, so you need to enter it here, and then you need to put the key which is metallurgy. But one thing which you have to remember here is this particular thing is a list. Okay, so then again you need to come to the next pair in the given conditions, and then you check the key and then the value chemistry is again existing, so you just need to enter this particular biochemistry key into this particular list. Okay, likewise you just create all the dependency map. Okay, this I call it as dependency map. Okay, once you created this, as I explained before, you just need to go one by one using the keys. Okay, these are the nodes which I already told you, right? These are the nodes. You just need to go one by one and then fill up the entire and then just go the entire path of the graph. And once you complete each and every node and you are able to finish all the courses, then you return true, or else you return false. Okay, so one thing you need to remember here is this particular case. Okay, what it says here is, you if this is the case, the map which we will get is, you have to enter the value 0, right? And then 1. Okay, this is the list. Okay, and then you come up here and then you say 1. Okay, so again you enter here list. Okay, so this is how you will end up. Okay, this is the dependency graph which dependency map which I talked about. Okay, so you will consider the node 0, so you have to move to 1. Okay, so that's done there. Okay, and then if you will check if there is any other node which is 1 in the dependency map. Okay, so you go there and you fetch 0, but the thing is, each time you do this, when you are going from here to here, you need to say this 0 as visited. Okay, so when you go to here and you try to come up to the next node which is again 0, you will check, because it is written here. Okay, the dependency map, you will check whether that 0 what you are going to visit next, okay, is visited or not. All right, if it is visited, then we will return false automatically, because obviously this the thing is, if there is loop, it is something like the conditions which are given are actually not valid. Okay, so that's the reason why you will return false. So based on the conditions which we see here, I have created the dependency map just to explain better. The arts, after you learn arts, you won't learn anything. Okay, because there is no course which is dependent on arts. Okay, so there are two courses, metallurgy and biochemistry, which are dependent on chemistry. So after learning chemistry, you can learn these two courses in an independent way. Okay, and the next one is medicine, which is dependent on biology. So once you learn biology, you'll learn medicine. Okay, the thing here is, you cannot learn oncology and medicine in a separate independent way after learning biology, because oncology is dependent on medicine again. Okay, so that's the reason why since oncology is dependent on medicine, once you learn medicine, you can go to oncology. Okay, so in this way, I'll just try to create a graph and I'll just try to explain it here. Okay, in this particular example. So in our dependency map, I can see 4 keys, right? Arts, chemistry, biology, medicine, right? So if you look at this case, the arts, so initially what you have to do is you need to take arts node, okay, and then you try to create a graph from it. So what you have to do is you need to traverse through the graph such that once you completed the course, what are all courses which are available in the map, so that I can take up and learn. Okay, once you completed arts, there are no since they're in the dependency graph which you've map which you have seen earlier, there are no courses, so that's why you cannot do anything. Once you learn arts, it's done. So you need to keep arts in an order list. Okay, but you can learn. Okay, so the next one is chemistry. Obviously the chemistry has metallurgy and biochemistry, right? So what you will do is you will learn metallurgy, but before that you will check such that the chemistry is visited. Okay, so once you move to metallurgy, and again if you move to somewhere else and you again come to chemistry, you have to say that it is visited again, so you just return false there. Okay, so but not in this case. So you will reach metallurgy, and then there is another child here which is biochemistry. Okay, so from chemistry you reached metallurgy, and since there is another child in the list in the dependency map, you again come to biochemistry and then say these two are visited as well. Okay, so this is we are done with chemistry. Now we are coming to biology. Okay, in the biology, the one thing which we have in the list is medicine, so you just directly keep medicine here. Before that, I just want to tell you this chemistry, metallurgy and biochemistry, you'll just keep it here. Okay, metallurgy and biochemistry. Okay, so these three are done as well. Okay, so total 4, 1 2 3 4. Okay, now you are coming to biology, and even though here once you come to biology, you just move, make it as visited, and you just go to medicine, because that's the only course which you have here. Okay, but one thing which you have to do here, keep in mind, is I am actually, after done with arts, I move to chemistry, but before and once I'm done with chemistry, I move to biology, right? But the thing here which you have to remember is, in the chemistry part, I move to metallurgy, and after I come back, I need to check if the metallurgy is again in this map or not. This metallurgy key, if I have in the map or not, I need to check. Okay, because what you're essentially doing here is you're going down to the depth of the graph. Okay, so once you do that, it seems that you are satisfying all the conditions. Okay, so that's the reason which you have to do. You have to go into the depth of the graph. Okay, so the same case, if you apply here, the medicine key is again existing in the dependency map. Okay, so once you reach here, you actually can reach here. I mean, the main thing which I'm supposed to tell here is the biology, after the biology is done, you need to check the next key, right? But the thing is, you're not checking the next key here. You are actually checking, since you reached medicine here as it's a value of the biology key. Again, you are actually checking if medicine is there inside the key itself. It's not like going to the next key. You're actually coming to this key from this value. Okay, so in the code level you have to take care of that. Okay, so in the medicine, once you reach medicine, you will again check if the medicine is there, and yes, it is there, and it is leading to oncology, right? So that's why you will have to go to oncology as well. Okay, but in the code wise, again there will be one more key which will be left out, right? But the thing is, this medicine you've already reached. Okay, so once you reach, you won't visit it again, but you have to check if it is again in the order list or not. Okay, the main thing why I'm telling you that is, medicine, see, when you reach each and every node, you have to put in the order list as well, because this is the final list which you are saying that the courses are completed. Okay, based on that list only you can say whether number of courses is equal or not. Okay, how many courses you can study based on the conditions that are given. Okay, so in this way you keep traversing the graph, and you keep filling the order list. Okay, so when I say ordered list, it means that each and in the list, the order which the courses are given, you have to take up in that particular order. Okay, so if you follow this this particular path, then you can come up with each and every course which you can take up, and finally you will be able to check with number of courses variable. Okay, this particular list length. Okay. So one important thing which you have noticed here is the path which you are taking is actually an algorithm, and by now you would have known it. It's actually depth first search. Okay, so using depth first search algorithm, you are actually able to solve this conditional scheduling problem. Okay, in which case here it is course scheduler. Okay,
So now that we have discussed all the solutions which we can come up with regarding this problem, let's dive right into implementing the solution. Okay, let's, as I talked about, let's try to create the dependency map. I'll say map, and I'll say set of integer. I'll say course map, and I'll just give new hash map. Okay. So this set presents all the courses which you can come up once you're done with the course as presented as key. Okay. So once we have this, let's try to populate this map, dependency map, based on the prerequisites which are given. Okay. Plus, and I'll just take course integer and prerequisites of I. Okay, so this is the number of courses which I can I mean, this is the condition, right? The prerequisite condition for one of the conditions in set of conditions, right? So this course really tells before I need to check, right, first of all, whether this is containing in the course map. Okay, so the course which I got here is course of 0, right? This course of 0, if I have in the map, then what should I do? I just need to append, right? So that's the same thing which I'm trying to proceed here with, as discussed on the board. Okay, so course 0 and add course of what? Yeah, one, right? Okay. So, or else what we'll do, we'll just try to create a new list for that particular key, right? So as discussed on the board, I'll just try to create a new list, which I'm going to take as set here, a hash set, and I'll just try to populate that particular new one. Okay. Sorry. Okay. So once that is done, I can say the map is completely filled up. Once that is done, let's come up with a parameter which is very crucial here, as I talked about, as I talked on the board, which tells us whether a node is visited or not. Okay. So let's come up with a list as well, the final list, which I call as order, since it is an ordered list. The courses in that list will be in one particular order. I mean, in sequential order. Okay. So now for each course in the course map, I mean, for each course, okay, we need to, I mean, these are the base courses, right, which you have to take from the beginning. Okay, you need to traverse the path, right? So for that reason, I'm trying to iterate through the course map key set. And first, while doing iteration, I mean, I need to come up with check whether it is actually visited or not, right? That particular course. If it's visited, it's not required. Okay. If it's not visited, then what we'll do is we'll call DFS, which will be written here. Okay. I'll come up to it later. But one thing which we have to remember is, as I've already spoken on the board, we need to add the particular course whenever you see that. Okay. One thing here is, before you even do before you even add that, you are actually trying to add call the DFS. Okay, this anyhow, this is a set here. As you observe here, it is a set. So even though you add it later, you can actually do the DFS traversal before itself. Okay, one thing here you need to remember is in this particular DFS function, even if that particular node arrives, you can add it there itself. And again, if you come here and I try to add this particular course, then obviously if there is a cyclic reference that occurs, we will definitely return false. That's not a big deal. But if there is no cyclic reference, then there is not, that's not a problem, because you've already creating this as a set, right? So the thing here is, if an existing element is already existing course is already there in order, then it'll just replace it. Okay, so now if I'll just try to call DFS on that particular course, and I'll just try to give course map and visited and order in this particular map and this particular function. Okay, just to make sure these are again populated in that particular function as well. Okay, so if it is not happening, then I'll return false. Okay, one thing is, once you're done with all these things, you actually don't need to check the length of the order list. Okay, because if there are any issues that happened here, the DFS will automatically has to return false. Okay, so that's the reason why I don't need to check the length, which I actually told before even I explained on the board, right? So that's why I specifically mentioning that here. Okay, sorry, this is written true. Okay, now we have to come up with writing the DFS function course map integer set integer. Okay, obviously it's a course map which I'm following. Okay. So the visited parameter and order. Okay, so now what you have to do here is, since you're calling this DFS on one particular course, you should say that you visited it. Okay, so that's why I'm taking the existing visited set and I'm trying to add that. Okay, once you're done with that, again you have to check from this particular course whether you can traverse to any other course. Okay, as I've explained on the board, you need to check the next child of that particular course. Okay, so based on the course map which we already have, we just check if it contains any other key in this particular course map. With that course, we will just check if it contains any other key. Okay, if it is existing, then it is like that particular key value will be the next child. Okay, so that also you need to visit. And one more thing is, it can have multiple children as well. Okay, so that's the reason why you are using for loop here. Okay, so let's say the required course, and the same logic applies here as well. Okay, yes, check visited. If it is not visited, sorry, contains required course, it's not visited, then what will you do? You'll try to again do the same DFS. Okay, this is like a recursive call. Okay, again you'll pass the course map, you'll pass the visited, and you'll pass the order. Okay, I'll tell you one more interesting thing here. Okay, so once this is done, you need to do the same thing which you have done before. You need to add it in the order. Okay, an interesting thing here is, if you already visited the node, okay, you can't just simply return false. That's actually wrong. Okay, what you have to do is, you need to check one more condition, which is, You need to check if that course, the required course, is again in the particular course map. Okay, and this since beginning we are trying to create, populate order, right? All the courses which we are trying to learn in some order. Okay, in that particular order, whether you have added or not, also you need to check. Okay, this is the actual giveaway here. Okay, this particular thing is the actual hint which you have to understand while coding. Okay, what it states is in a cyclic graph you are actually trying to visit. Okay, what visited tells you is it will tell you whether that particular node is visited or not, which means it is not like a cyclic thing by default. Okay, it is only cyclic in a way, like only if you add that particular value in this particular order by that time. Okay, at that particular time, if you've or if you visited, and then and again you and one more thing is, if you've added that course in the order, if those two conditions match, then it is like a cyclic case. Okay, so that's why we'll return it as false. Okay, so these are the two conditions which you have to remember. Okay, based on the logic which I explained on the board, the implementation is done, and let's see if this works. Okay, I think there is some compilation errors. Well, I fixed most of the compilation errors. And I had a bit of variable declaration issues. The variable I've written as wrong in some cases. So this is the final code, as you can see. Okay, so let's try to run it. Okay, so it's accepted and all the cases are finished executing, and they ran successfully. So this is how you solve these kind of scheduling problems, and I hope you understood this particular depth first search related problem, and I really hope you'll be able to solve it in if you ever come across these kind of problems. Thank you, thank you for watching. Be sure to subscribe the channel.